Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture we'll discuss a topic regarding types of fluid flow. So this types of fluid flow is coming under the topic under kinematics of fluid. So in the kinematics of fluid we are going to study the types of fluid flow. So these types of fluid flow actually it is categorized into 6 different types. So first one is steady flow and unsteady flow. First one is steady flow and unsteady flow. And second one is, we'll discuss one by one. Let me first write these things. Second one is uniform flow and non-uniform. Non-uniform flow. Third one is, we can write compressible. Third one is compressible and incompressible flow. Yeah. Next, fourth one is rotational and irrotational flow. Fourth one is rotational, irrotational. And next is, fifth one is laminar flow and turbulent flow. Laminar and turbulent flow. And the last one is nothing but this is one dimensional and two dimensional and three dimensional flow. Okay, these are the types of fluid flows are there. So we'll discuss one by one all these flows. So first let's discuss about the first one. What is steady flow and what is unsteady flow? What is steady flow and which is unsteady flow? So steady flow actually it is the fluid flow in which the fluid characteristics, okay, the fluid characteristics means, so let me write the fluid characteristics means we can consider rho, that means density, pressure and velocity of the fluid, okay, at a point do not change with respect to time. Do not change with respect to time. So what it means, suppose there is a flow is there in a pipe, okay, and if you consider in the pipe, this is the suppose fluid flow is there, and let consider a section of this pipe. So this is, let consider one section is there, okay, section 1 suppose, at this particular section, okay, and let find out the density of this fluid, pressure of the fluid and velocity of the fluid particular at this section at a time. At which time, let suppose the time is now 9 o'clock and this time you can write at time t equal to, you can write suppose 0 second or 0 minute, that means the starting point, or you can say 9 o'clock, okay, this one you can write this is 9 am suppose. At time 9 am, what is the density of this fluid, what is the pressure of the fluid and what is the velocity of the fluid, let measure it, okay. At the same point, okay, after 1 hour suppose at time t equal to 10 am, okay, at time t equal to 10 am, again we are going to measure this same characteristics of the fluid like density and pressure and velocity of this point. Then if you get the same value here, if the value is same, then we can say this flow is steady flow. That means there is no change its properties or fluid characteristics with respect to time. at a particular point, So what we can write, the equation for this, we can write del rho by del t equal to 0. Okay, and similarly the other properties also you can write. Okay, del v by del t with equal to 0, and this is at a particular point. Suppose if you take any directions, so that will be at whatever it may be, x0 or x1, y1, z1 at a particular point. So this is at this condition, at this point, at a fixed point. This is the point what I am mentioning here. At a fixed point, this will be the conditions. So there is no change of this fluid characteristics at a point with respect to time. It is not going to change anything. Okay. Similarly, the unsteady flow will be the alternative of this one, or opposite of this one. So unsteady flow is nothing but same. We can consider unsteady means unsteady flow. If you consider the same pipe, and as I told you, let measure this fluid characteristics of this characters like density and pressure and velocity, and if you are going to get the fluid characteristics changes with respect to time, here it do not change, and in the steady state, if you unsteady state, it is going to change. Which is going to change? Now the characteristics of the fluid. If it is going to change with respect to time, then it is called unsteady flow. So for this, what we can write? Now del V with respect to del T is not equal to 0 at a particular point, So that one also we can write in such a way, bracket x0, y0 and z0. This one we can give in a bracket also. Similarly, we can write also del P by del T is not equal to 0, and same at this particular point. So this is about the steady flow and unsteady flow. Okay. Now the next one is uniform flow and non-uniform flow. So uniform, non-uniform also simple. So let me write here. I'll take it. Another one. Second one is uniform flow and non-uniform. If you understand uniform flow, then non-uniform also simple. So again, let's consider the same thing, like similar kind of diagram, where this kind of, suppose one diagram is there, some kind of liquid is flowing inside this pipe, suppose. Okay, so which one we can say uniform flow? Let's see. Okay, now here also fluid is flowing, here also fluid is flowing, and at this point also fluid is flowing. So what do you mean by this uniform flow? This uniform flow is nothing but it is defined as the type of flow in which the velocity at a given time, does not change with respect to space. Okay, velocity does not change with respect to time or at any time with respect to space. That means the space in the sense we can say the length in the direction of like which direction the flow is flowing, in that direction you can consider. So suppose this is the length is there, in this length, this is the length is there, in this length what is the velocity is there. Suppose a particular distance we can consider, this is the particular space. Okay, so at a particular space the velocity should not be changed, everywhere same velocity should be there. Okay, then we can say it is a uniform velocity. Okay, then you can say it is a uniform velocity, not uniform flow. So what you can write for this? Now del V with respect to del S, del V with respect to del S equal to 0. And one more thing, we need to consider the time constant at a particular time, as I told you. Okay, just you can note down this definition. What is the uniform flow? Now uniform flow is, or uniform flow can be defined as the type of flow in which the velocity, this velocity at any given time does not change with respect to the space. This space, the space is nothing but this is del S. Okay, that is nothing but the length of flow in the direction of fluid. Okay, so this is the uniform flow. Similarly, if I talk about the suppose non-uniform, opposite of the uniform one, that is non-uniform, you can write non-uniform also, simple one. Again, similar condition if you consider, okay, the velocity is going to change, the velocity of the flow. Now see, at this all this region the velocity is constant, suppose. Okay, for this non-uniform flow the velocity will be not constant or not same with respect to the space. So what we can write in this, now del V with respect to the change in velocity with respect to change in space at a constant time t equal to constant is not equal to 0. What is the meaning of this? Now the fluid flow in which the velocity at a given time, okay, changes with respect to space. Okay, this velocity with respect to space, it is going to change. Suppose the velocity here, what is there? So 3 meter per second. Okay, and when it is coming to this next one more space, if you take from the space from here to here, suppose. Okay, let's consider this is the space, and here if you measure the velocity is 3 meter per second, and now if you measure the velocity here, that may be given you suppose 5 meter per second. That means the velocity is changing with respect to space at a given time. That means it is not fixed. So that is called non-uniform flow. Okay, so next one we'll see third one. So third one is compressible, incompressible flow. Third one is compressible and incompressible. This is also simple one. So the meaning, the name itself, it's talking about the compressed. That means when the fluid flow is there, suppose there is a pipe is there and there is a fluid inside the pipe, and the fluid is flowing inside the pipe. These are the liquid particles, which is not visible obviously, just I am giving a layer of this liquids which is flowing inside this. So this is the flow direction, inlet part and outlet part. Okay, now in this if you see, you just can put one pressure gauge on this, okay, to see the pressure value at this point and this point. Now compressible fluid means what? Now when the fluid is ready to compress, okay, when the fluid is ready to compress, so this is the fluid is there, and if you see, you can put one obstacles here or some kind of orifice meter if you keep in the middle, and you can see there is a changes of fluid, and the, it is going to compress in this. Okay, so this is one example of compressible. Like another one example I can show you. Suppose let's take a container here, a simple example of this. Now here in this container, full of liquid is there, and any liquid may be there, any kind of fluid is there, and if you give a press on this, or if you give a load on this, okay, and when you are trying to compress on this one, so you can find out that this fluid is ready to compress, and after this applying of this load, you can see the next level, you can see. So what is going to change? Now it's after compression, you can see the fluid came to in this level, okay. Now you can see that changes of this, what this is the changes of its height. So here we can say on behalf of height, we can say the changes of its volume. The volume of this fluid is changed. So this compressed part, we can say it is directly related to the density part. So we know that density of a fluid equal to mass by volume. So now if you see in this part, your density equal to mass by volume. So mass is going to same. What is the mass of this object is there or fluid is there? The same mass will be here also. But what about this volume of this fluid which was in this container and this container? You can see the volume was decreased from this point to this point. So here the volume is going to change. Then we can say the density also changed. Correct. So this fluid is called compressible fluid. So that we can say the compressible fluid or flow in which the density of the fluid changes. Point to point it changes. Suppose here one density is there, Okay, here another one density is there. That means the flow is a compressible flow. You can say the density is changed, or you can say the density is not constant. Okay, so this is known as compressible flow. And similarly, incompressible, opposite to this one, the fluid which is not ready to compress. How much load if you give, still the fluid is not going to compress. That means the density is not going to change its value. Okay, same thing, I can consider a container here. Suppose let consider a container, and inside here liquid is there, and if you apply some pressure here or load here, okay, even after giving some weight on that, you can see in the next level also the same same volume of liquid is present here. So if your volume is not going to change, the mass is fixed, so mass is also not going to change. So mass not changed, volume also not changed, so density is not going to change. So that means density equal to, we can write density is going to constant. There is no change in the density part. So this is about the compressible and incompressible fluid. Now we'll see in the previous what I have written. Fourth one, yeah, rotational and irrotational. So rotational and irrotational also simple one. So this is the fluid which is rotating around the axis of the fluid. So I'll tell you, rotational. This is very interesting topic, the types of fluids. So this is rotational fluid flow. Okay, so which one we can say the rotational fluid flow? Okay, suppose the fluid is flowing. As I told you, the fluid is flowing. So let's consider a line here, and this line is the streamline of that particular. You can say the fluid which is flowing. So this is the streamline of that. So where we can say the fluid flow is a rotational flow. We can say when the flow in which the fluid particles while flowing, suppose this is the flow is there, give the arrow mark of this. When the fluid is flowing, the fluid particles of this, okay, and flowing along the streamline, it is fluid particles also is moving along the streamline. Streamline is nothing but the fluid, the path which is not going to interrupt with others one. It is only going to move along only in this particular direction. It is not going to interfere to other fluid layers. So that is streamline. And also it is able to rotate along the axis. Axis is nothing but the streamline. The fluid can able to rotate along the streamline, or you can say about the axis. So that is called a rotational flow. Okay, the fluid is able to rotate along the axis of this line, or you can say about the streamline of that. That is called rotational flow. So similarly, irrotational flow also, this is also simple. Irrotational flow, which we can say irrotational flow. Now, irrotational flow, where you can say the fluid particles while flowing, while the fluid is flowing, the fluid particles along the streamline. This is suppose fluid particles are there along the streamline, means along this own axis. Okay, it is not going to rotate along the streamline. So here it is possible to rotate along the axis. The particles are going to able to rotate in this, but in this case the particles are not able to rotate along the axis of this line, or you can say along the streamline of this object. So in that case it is called, you can say this is a irrotational fluid flow. Okay, now the next one we'll see. The next one is very simple. This is the fifth one, that is laminar flow and turbulent flow. So laminar flow and turbulent flow is very easy. Laminar, turbulent. One more is the actual transition, but we are not discussing that one transition. I'll tell you which is transition also. So laminar and turbulent, actually So how to define this laminar and turbulent? So while defining this, or while you are writing this definition of this laminar, you can say, okay, when the fluid particles move along a defined path or a streamline. As I told you, when the fluid is moving with a path or a streamline, it is moving like this. Suppose the fluids are moving in this way, such a way. So along a straight line, or it is parallel to each other. You can see the layers of this fluid which is parallel to each other. So they are moving its own way. So this is called streamlines. So the particles moves in laminas. The particles are moving in the laminas, and layer, if you see this layer smoothing over the adjacent layer. This is one layer, this is one layer. So all are different layers are there. All are moving. So this type of flow is called streamline flow, or we can say viscous flow. We can say viscous flow. That means there is no disturbance of this fluid over layer to layer, or we can say this is streamline flow. Okay, or also you can call it as this is laminar flow, viscous flow, or streamline flow, or we can say laminar flow. So which one you can say turbulent flow? Now turbulent flow, in which similar thing, the fluid particles move in zigzag way. You can say the fluid particles are moving in zigzag way, and there is no proper layers formations. Okay, they will be moved here and there like this, and there will be eddies formation will be there. Okay, zigzag way, and the eddies formation also takes place in this. So here the eddies formations will be takes place, and it is moving in the zigzag way. It is moving in the zigzag forms. Okay, so that is, you can say, a turbulent flow, and there actually mostly we used to find out there is a lot of energy losses used to happen in the turbulent flow. Okay, now so how to define, or how to identify that which is laminar flow and which is turbulent flow? For that also actually a formula is there. Long back, like Reynolds, one scientist was there, he given one formula in his name, like RE equal to rho V D by mu. This is the formula. Based on this, we can identify whether the flow is laminar flow or whether the flow is turbulent flow. And this is only applicable when the flow in a pipe flow is there. When there is a pipe flow, for the particular pipe flow, we can say this is the formula is going to apply. Now, here R equal to Reynolds number, and rho equal to density of the fluid which is flowing inside the pipe. V is the velocity of the fluid flow. D equal to diameter of the pipe, and mu is the dynamic viscosity of the fluid. So based on these, we can find out whether the fluid is Reynolds number, whether the flow is laminar or not. So the Reynolds number, if it is within 2000, if the value of Reynolds number is within 2000, then it is called laminar flow. Okay, if the value of Reynolds number is more than 4000, when the value of Reynolds number is greater than this, okay, then the flow is called greater than this, and this is less than this. Then we can say it is turbulent flow. So how we can find out this value? Now for that we need to consider the density of that and the velocity of this, and diameter is fixed. See, diameter is fixed, density is fixed, viscosity is fixed. Only the changes is happening velocity. So velocity takes a crucial role in this to identify the laminar or turbulent. Okay. Now, if it is less than, then laminar. If it is more than, then it is turbulent. In between 2000 to 4000, if the range is there, then that may be laminar or maybe turbulent, it says. But actually, that is called a turbulent transition flow. That means the fluid is going to change its flow from laminar to turbulent. So that is called transition flow. So this is about the laminar and turbulent. I hope you understand this one. Now the next one is last one. I'll close it here. That is one-dimensional, two-dimensional, and three-dimensional flow. This is very simple. Okay, when the flow is moving only one direction, that is, we can say the fluid is only moving in one direction in the pipe. Suppose let fluid is moving in this. Okay, and only one direction, one space only we are going to consider, then it is called a one-dimensional flow. I'll tell you the definition. And two-dimensional also when the fluid is moving in two dimensions, like two dimensions, two spaces. Suppose this is, if you take this one x direction only, and two dimensional we can consider x and y direction, and similarly 3D means x, y and z direction. So this is only one direction, this one we can consider, this is y and this is x, and if you take 3D then we can consider x, y, z. This is x, y, z. Okay, this all this direction if you consider. Now this is okay. Now which one or how we can write the one-dimensional flow or something? So one-dimensional flow is nothing but you can say in which the flow parameters, okay, such as velocity. If you consider the velocity, such parameters velocity is a function of time. You can say the velocity is a function of time, and it's moving only one space coordinate. As I told you, it's moving only one space coordinate. Space in the sense only along with the length. Suppose if you consider only one space coordinates, and this also we can write, this is if you write equation wise, then velocity is a function of, you can write fx. And what about the u? Here I will written u is a function of fx. What about the v? Now v is here 0, and if you write w, that is also 0. That means the velocity along the y direction, along the z direction, both are 0. Here we have considered. This is for the one-dimensional. Similarly, if you consider the two-dimensional also you can say in this the velocity is a function of time, and we can say it is a rectangular space. This is the rectangular space type as I drawn here. Okay, in this space x and y direction, the velocity is a function of two coordinates, x and y coordinates. Okay, and the variation of fluid flow in the third direction is negligible or not there exactly. So here what we can write, the u equal to is a function of x as well as y, two are there, and similarly v is a function of, you can write f1, and here you can write function of 2. Okay, that is here x and y. So two functions are there. But what about the w? W will be 0 because there is no in the third coordinates. Similarly in the 3D, again we can write the velocity of a function is a function of time, and it is all direction mutually perpendicular to all, like x is perpendicular to y, z is perpendicular to y, y is perpendicular to x, z. So all are mutually perpendicular to each other, and this is three-dimensional fluid parameters is a function of three space coordinates. Okay, and here we can write what? Now u equal to, similarly as I written there, x, y, z. U is the function of x, y, z, and v is the function of again f2. We can write x, y, and z, and similarly w also we can write f3. Just have taken different parameters, and here x, y, and z. So I hope you understand, like what other flows are there, 1D, 2D, 3D, and this laminar and turbulent. So very simple actually. You can remember this concept so that it will be not difficult for you when you are writing the exam. So no need to even remember also. Just you got the concept how to define, then easily you can write the definition, and you can draw some diagrams for that. Okay, so what we discussed here, different types of fluid flow like steady and unsteady. Steady is here the properties of this fluid. Okay, it's not going to change with respect to time. Okay, then we can say steady. If it changed, then we can say unsteady. Uniform also, the velocity with respect to space of time. The velocity is not going to with respect to space at a particular time. Okay, this is the space is there, velocity is all over the space is same at a particular time, then you can say uniform. If the velocity changed, as I told you, with respect to over a length of space, then this can be called as a non-uniform. Similarly, compressible, incompressible, when density is matters, density is changed. After compressible, density changed, then it is compressible. Incompressible, density is not changed because it is directly related to the volume. Rotational, when the fluid is able to rotate along the own axis of the fluid, then it is called rotational. And when the fluid particles is not able to rotate along the streamline or along the axis, then it is called irrotational. Laminar flow and turbulent 1D, 2D, 3D, what we have discussed here. Like based on the Reynolds number value, we can define the laminar flow and turbulent flow. And these are the 1D, 2D, 3D. So I hope you understand how to remember these types of fluid flows. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.